Hi guys. So this is part 2 of our math workshop. So I'm going to go back to our learning intentions for today. Today we're going to explore efficient strategies for multiplying by 11. And today we're going to continue solving two-step story problems which you did in the previous video. Success criteria: by the end of the lesson you can multiply by 11 efficiently, and I can solve two-step problems independently. Your language intention: even though we're not in class to practice the language intention, you can still practice saying it out loud. You might say something like, in order to multiply by 11, I have to, And social intention: I can work on my assignment independently, even when no one is looking. So if we look at the meat of the lesson today, which is multiplying by 11, we're going to start off with this problem. Make sure you have your math notebook in front of you in case I ask you to jot anything down or do any math work in your notebook. So Zach uses base 10 area pieces to build this picture of 3 times 11. John uses base 10 area pieces to build it a different way. So the first thing I'm going to ask you to do is just to notice the difference between Zach's way and John's way. So take a moment to just observe what you see. And then now you're going to open up your math notebook, and we're going to be doing a lot of writing in these upcoming videos. So you're going to write down a difference between Zach's way for multiplying 3 times 11 and John's way is Make sure you're using juicy mathematical words. And pause it to write. Right, so that means you had an opportunity to write down in your notebook the difference between Zach's way for multiplying 3 times 11 and John's way. You might have said that Zach's way, for Zach's strategy, he used equal groups, which is, we've talked about from the beginning of the year, multiplication can be represented as equal groups. So let's add that to our math notebook. So a difference between Zach's way for multiplying 3 times 11 and John's way is and John's way is that Zach chose to use equal groups to represent 3 times 11. However, John chose to use an array, or you say at home, area model, which is something you're going to see in 4th grade. So he chose to use an array or area model. We're going to take a closer look at Zach's way. So I'm going to make sure he did represent this with equal groups. So I see 3 equal groups, and so my number of groups are 3, but then I look at the group size, each one has 11, so we do have 3 times 11 represented there with equal groups. So I'm going to write 3 times 11. And when we do that, we can also use repeated addition. That's probably what Zach did, right? So he probably added 11 plus 11 plus 11, or he might have skip counted. He might have said 11, 22, 33, which gives us a product of 33. Give yourself a little pat on the back if that's what you also noticed. But John's way is interesting because it's slightly different. So let's look. This is called an area model or an array, which we've been using all year long. If we look at the dimensions here, we have 3 rows, or we see that our height is 3. And if we look this way, our width, our number of columns, interesting, it's not 11. What's shaded is 10. So if I were to write an equation for that, I would put in parentheses 3 times 10. And then I have these extra 3 that are not shaded. I wonder if he used 3 times 10 as a way to get to 3 times 11 in a more efficient way, because he's adding just another group of 3. Let's see if that still gives us the same product of 33. If 3 times 11 is equal to, in parentheses, 3 times 10 plus 3. So if I multiply 3 times 10, that gives me, yep, you said it, 30, and then I'm adding 3, definitely gives me 33 as well. Now, part of your question that I want you to think about is, which way do you like better? Is it easier? Is it more efficient to do equal groups like this and count every group and the group size? Or might it be more efficient to use an aerial model such as this one and just add an additional group of whatever is needed in order to complete the equation? Pause to think. All right, so we're going to practice multiplying by 11. The next part I want you to notice, there's a lot of noticing going on today. I want you to look at these equations. We have 2 times 11 equals 22, 5 times 11 equals 55, 7 times 11 equals 77. I want you to look at the relationship between the factors, such as 2 times 11 and then the product is 22. I have 5 times 11 and then the product is 55. What are you noticing? You're going to open up your math notebook, just go down a little bit further, and you're going to write, I notice. So if you noticed that when you multiply a number by 11, the same number is represented in the product twice, you are correct. However, this only works if you are multiplying 11 by a digit that is smaller than 10. So anything between 0 and 9 would be the strategy for multiplying by 11. But I also want to show you that you can use the strategy for multiplying by 11 and just adding another group of. So we're going to try that with 11 times 11. So I want you guys to write it out with me. Whatever I'm writing, you can write with me as well. So 11 times 11. And then I'm thinking, I can multiply 11 times 10 because multiplying by 10 is an efficient strategy, and we learned earlier this year that when I multiply by a multiple of 10, I can just multiply 11 times 1. That gives me 11, and then if it's a multiple of 10, I can just add this 0 down here. So really this is 110. But I'm not done yet because it's 11 groups of 11. So I still need one more group of 11. So 11 plus 110 would give me 121. Which is the same as if I were to just multiply or do 11 equal groups of 11, it would also give me 121. As a bonus, I want you to try that with 12 times 11. And you can, if you can add in the comment section the answer that you got to 12 times 11, and I can respond to you guys tomorrow. And I want to see not only 12 times 11 what it is, I want to see it represented as this equation, meaning that you're decomposing it to multiply. And then lastly, so you can get some independent work time, you're going to open up your Bridges workbook and you're going to complete page 224 that says Math Family Night. If you have any questions, make sure that you tell your parents to message me, or you can always email me at shazi.maldonado@caminonuevo.org. You can have your parents add me on Facebook. It's MS Maldonado together, CNCA. Or you could also have them message me through Parent Square. All right, guys, see you in the next one.